Hey folks, over the past month I've been using this, the Asrock Challenger RX 5700 XT, and it's been a journey of ups and downs. If you're familiar with the channel, then you're going to know that prior to this, my main GPU of choice was Vega 64, and it really come into its stride lately, comfortably pulling ahead of my GTX 1080 in terms of performance, while offering up a great feature set of software which has made the whole experience both very tweakable and really reliable. So it was only natural that the RX 5700 range would tickle my fancy a little on release, and I'll give Navi its dues first and foremost. A 25 to 30% performance bump on a GPU half the size is nothing to be snuffed at. But this video today, it's not about raw FPS numbers. No, today I wanted to talk about the Challenger in particular, and my experiences so far with Navi as a whole. It's a card which hasn't really grabbed the headlines in the same way that, say, Sapphires Pulse has, nor has it been in the news in a bad way like some of the other Navi cards. No, instead it just seems to exist. And now it's even been overshadowed by Asrock's own Taichi models. Now I'll get one thing out of the way first off, this card was almost returned. When I first got it, Navi was, well, it was a pretty awful experience. The software side was absolutely miles behind what I was used to with the Vega cards, and it didn't even function on my 75Hz 1440p monitor, having to drop the refresh rate down to 60Hz to get anything running. But after much contemplation, I decided against returning it and decided to wait it out. And at the start of October, AMD released their 19.10 driver, which for me has seemed to iron out many of the issues that I was having with Navi as a whole. But the Navi experience aside, what about the card? Well, compared to my old Nitro Plus Vega 64, the Challenger is, well, it's very compact if I'm being polite, and possibly a little bit malnourished if I was going to be critical. Compact is going to be great for some of you, especially if you're looking for a true 2-slot card which offers GTX 1080 Ti-like performance or RTX 2070 beaten performance. It's great, but that compactness does come at a cost. The smaller heatsink used means that the fans will need to ramp up quite quickly, and they tend to level out about 60%, which is about 22 to 2300 RPM, which is by no means silent. Now it's not noisy or unpleasant, with my system returning values around 42ish decibels when measured from my seat, and it's quieter than my XFX RX 580 and even my Vega 64 before it was undervolted, but it is noticeable. Now booting up the card in stock configuration but locking the fan speed to a steady state of 60% and running it through the 10-minute Firestrike Extreme stress test, there's a few things that stand out. Firstly, the boost clock averages out at 1855 MHz, with a peak clock of 1992. Now this is considerably higher than the expected and advertised game and boost clock speeds of 1795 and 1905, so we're off to a good start. Power draw though, well, it was also on the higher side of things. A peak power draw of 231 watts, which is taken from GPU-Z, and an average power during the duration of the test of 190 watts. What the higher clocks and higher power draw does mean, however, is higher than needed temperatures. Now, these temperatures are well within specification. The card isn't overheating, it's not throttling. And with the card being able to keep within spec at a fan speed of just 60%, there is plenty of headroom to spin faster and cool better. But as I mentioned, the 60% fan speed was just on the cusp of being a bit too intrusive when it came to noise. But that said, the GPU package still only gets to 79 degrees, which is perfectly fine by anyone's book. Now, unlike Nvidia, AMD also allows the user to see the hotspot temperatures, just like they did with Vega, and this is simply the hottest value reported by any one of about 64 sensors across the whole GPU. Now at stock, this peaked at 95 degrees, which I'm sure some of you will be gasping in awe at such a high temperature, but you've got to remember this is the single hottest point on the die, and it's still well under the 105 degree limit set by AMD. Nevertheless, there is always room for improvement, and while I don't particularly like the Wattman implementation on Navi with its 3 control points and a curve compared to Vega 64's 8 separate states, the GPU itself does respond rather nicely to a bit of tweaking. At stock, the Challenger is set up in Wattman with a target clock speed above 2100 MHz and a maximum permissible voltage of 1.2 volts or 1200 millivolts. Realistically though, With a compact cooler and no power offset, that boost target is going to simply be unachievable. We've just seen that the max clock speed running through the stress test was just shy of 2 GHz and the average was just over 1.85, so by dropping this figure firstly down to something more reasonable like 1975 MHz, it's a good place to start. Next up, more voltage means more power, which means more heat. It's a vicious cycle, so by dropping this down from the allowed 1200 mV, you're going to reduce heat. You should certainly be fine dropping it down to 1100 mV, but by dropping in increments and stress testing that profile, you're going to be able to find the level your own card is comfortable with. Although we can get it lower, I'm going to stick to 1050 mV for this video, as this is a level that many RX 5700 XTs should comfortably be able to hit. With this undervolt in place, a few interesting things happened. Firstly, power draw drops on average from 190 watts to around 180, with the peaks dropping from 231 to 209. This has a knock-on effect of lowering the VRM temperatures, which dropped from around 80 degrees to 76. We knock a couple of degrees off the GPU temperatures at the same time, with the max GPU temperature dropping to 77 and the maximum hotspot temperature dropping to 92 degrees. Not a massive difference granted, but it's the clock speeds that we see a nice surprise. At stock, the average speed levelled out at about 1855 MHz. Undervolted sees the Challenger repeatedly average out at over 1900. Now true, the absolute maximum clock speed seen was lower, 1942 MHz compared to 1992, but as you can see on the chart, there is considerably less fluctuation and a much flatter, much more stable plot for the clocks. Lower temperatures and higher performance, I think we're onto a winner. And this is really how I've been running the Challenger so far, and it's been rock solid, so the temperatures in real world applications are a good bit lower than I'm showing you here, even more so if you use Radeon Chill. Now I've not even touched on the power slider yet, and for those of you that might have the card in a smaller chassis, or even if you just want to lower the power, lower the heat, and thus lower the fans a bit, the slider is your friend. By taking the card back 10% on top of the undervolt, you're going to further drop the hotspot temperatures into the 80s, and the GPU temperature will head down to the low 70s. Power draw here averaged out under 170 watts, with the maximum draw dropping down to 194. Now this obviously has a negative impact on clock speeds, but if you look at the figures quoted on the box, 1795 average game clock and 1905 max boost, which is already above the reference RX 5700 XT quoted speeds, we still managed to sneak past that, with an average game clock speed of 1812 MHz and a maximum boost seen of 1910. Now overclocking is perhaps a video for another day, but that's the Challenger in a nutshell. A decent honest card which does the job at stock, but can be improved simply and easily on all fronts with some subtle software tweaks. Now for what it's worth, I tore the card down and tested it with Thermal Grizzly Cryonaut, and there was virtually no difference whatsoever, so ASrocks' application of thermal paste is spot on here, and there's no benefit from reapplying. Likewise, both the VRM and the GDDR6 memory modules are properly heat-synced with well-sized thermal pads. So any tweaks will be software related rather than DIY mods, which is needed on some of the other cards available. So in the end, I didn't return the Challenger. The driver improvements came just in time for me to find out it's actually a tweakable and well-performing card. Not the quietest, but certainly one of the more uncommon Navi based cards available, and depending on what price it is for you locally and if you like the looks, it's one to consider. Not the best of the best for sure, the Taichi or the Nitro Plus look to be top of the stack for me, but as a good aftermarket RX 5700 XT, it's certainly worth a look. And the way that I see it, the more vendors that continue making cards, the better it's going to be for us as consumers, so I'm more than happy in this instance to take the punt on the ASRock card. I'm sure as time goes on though, Navi is going to continue going from strength to strength. In the face of the RTX 2060 Super and the older RTX 2070, the RX 5700, in whichever guise you choose, offers much more usable performance. And I for one am pretty glad that I kept it, and I'm looking forward to seeing how the RX 5700 XT user experience gets better and better as time goes on. But I think I'll leave it there, there's a lot more for me to do tweaking this card. So I'll just say thanks for watching, take care, and I'll see you in the comment section down below, and in the next video.